Hello everyone, welcome to the stream. How are you doing? I need to hear your voice. Does this run? Okay. Hello David, hello Dutch, hello Johnny, hello Jordi, and hello Streaming Elements. Hey Jumbo, I need a booster, not sponsored. Booster sugar free. Hey Sonic, hey Kaspar, the Sheepo, Dutch, Lazy Kaspar. It's not lazy, it's wazy. So, I wasn't lazy. What was the last state you saw? The last state, I saw that 32. Oh, maybe I have even. I can show the footage. I cut the ribbon cable, not the ribbon cable, the flat flex PCB in two. Let me show that. Here we go. Of the device and destroyed it. I can show you a piece of the PCB. Here it is. This is the piece of PCB that I destroyed. Audio is low. What are you? No, it's minus 15 dB. Isn't that alright? That should be alright. So yeah, the last state. Let me check if I have minus 10. Okay. Let me adjust it at the mic here. All right. Okay. Now we are at minus 10. That should be alright. When I scream, it's all your fault. Hey, cool pet. Hey, Foo. Let me check if I have. It's loud. Now it's cutting off. Hello, it's minus 10. Jordi, are your headphones, wireless headphones, charged now? I wanted to show. Oh wait, this doesn't work. Yeah, Jordi's. Yeah. Evil Jordi. I'm trying to my card reader, SD card. Okay, excavator fund and 4,085, another 4,000. Now I need to convert this to 8,000, which is 170. All right, here we go. Not spoiling the fun. Foo 170. Now, are you kidding me? What is it? 55, 2.55. Trolling. You know what? I can do conversion, automatic conversion, and then say thank you, Johnny. That's 65. SCK is 5? What? 5 euro? What? Oh. Do you hear that? Thunderstorm. That's when I'm gone, we might lose power or something. We are remote here. That's Hurricane Erin. So you Americans, you should have kept your hurricane. It's now bouncing back to us. I'm a Boyd. Hello. Hey, lines and squares. Watermelon. Hey. I missed a few people here. No wind here, Dutch. What? I mean, it's coming. It's coming for you. We need to zoom out. Do you see that? This is Hurricane Erin. This is Hurricane Erin. It's coming back to us. It's coming back and it's sending bad vibes. At least it's like 27 degrees here right now here. It was really cold the past days, but we get finally some rain. Oh wow, nice. My grass is growing. Cool, but you need your Hurricane Erin back. All right. What I wanted. Why isn't my files showing? The files aren't showing. Come on, show me the files. This is not working. I hope I didn't destroy my card. Okay. This should show it, yeah. Alright, so now it's raining finally. I ran out of my rainwater collection. Okay, peeps. Some footage that I still didn't copy yet. That was our fail. Here. You're witnessing power machine. Wow. Okay, cool, but just send me something. DM me on Discord. Yeah, I'm trying to cut off this. Oh no. Do you see that? Yeah, out of focus. Yeah. And then you can see the pubic hair here. And demonetized. So maybe we can see it here. Oh yeah. Look at that. 32 wires. 32 wires. I saw that each of those. This is the dread. Look at this. Look at this. Oh, the pain. But it didn't work. It was broken. They were broken. I needed to bridge them, and I have the documentation for that. Where's my printed? I had to print files on paper. Where are they? Oh, here. So PCB dreadlocks, yeah. Yeah, look at this. Look at this. I numbered all of those and had to scratch open. This is not numbered. No, wait. Is there numbering? yeah, basically here is the match. Here is the match, and I had like to scratch up some vias to access that. Sometimes I needed to trace it, but everything was accessible. And I used like the thinnest enameled wire ever. It took me a few hours to fix that. So, what's the current state of the device? Now I spoiled it. Here it is. Here it is. Let me plug it in. You only hear the rain. Okay. So it did something. Now I need to find the desktop. Yeah. Maybe we have some here. Okay, peeps. Let's just... Did we connect already? No, we didn't connect. Okay. Let's connect to the tape drive and read from file. Ta-da! Okay, this is a test TXT file. It's stored. This is like the sync signal. This is the one for successful load. Then we have the count of bytes and then the contents of the file. This is web serial. For now, we need to... Wow, this is pouring. Maybe I close the window here, otherwise... Oh, nice. What type of tape? I show you. But I had to change the frequency. Here. Loop! Micro cassette! Here. There is my file. Now I need to cut the video until this weekend. Oh, what? Yeah. Yeah, I bought a few and I like got some for free. Oh. Are there different types? Anyways, peeps, you want let me do that. I want to have like it detected. Oh, we need, yeah. So I have what is vice binary and oh really? I think this one was the exact one. Here we go. We start vice. Okay, this is C64. Now I have some cartridges that I download, but I don't know how to control everything. You can't read this. Okay. Anyways, we have Pac-Man. Let's do details. That's 9 kilobytes, almost 9 kilobytes. Okay, let's upload Pac-Man to tape. Uh-oh. Oh, 9. It failed. I think it failed. it failed. I don't know why. No, it's probably a power issue. I have no clue. I recorded already on this one, so let me reinsert it. Yeah. Let me replug it in. Yes. But okay. Okay, let's try again. Oh, now it's recording. We have to wait for the click. Demo gods, yeah, this is the first time it failed. I think it was a power issue, the cassette was not put in well. So it takes a few seconds to store the 8 kilobytes. We are storing at 1 kilobit per second. So it's 8 times 8, it's half a minute. No, wait, 64, it's 1 minute to store everything. Still recording. 1 minute for 8 kilobytes. I could, but I we can. Okay, now it's rewinding. Now to be sure. Hey Dan, how are you? Okay, now we can read the file from tape. It will also take a while. Uh-oh. What? Didn't it record? Oh no, it didn't. Oh, we didn't record from the start. You know what? I want, before we continue with that, as demo gods are not on my side, we can do like the dropping the file also as a file as soon we read it, okay? So let's do this first. Everything is committed, so if you are wondering. Yes, of course, VHA. Yeah, of course. Okay, so make download link bytes and okay, so we read files up there somewhere. Read data, decoded block, log data, if data loaded, and then we need to make download link, but we need to wow, the thunderstorm is heavy. I want the first part of the data is like bytes. Yeah, I ask ChatGPT. Okay, text decoder. Okay, text decoder. Decode the bytes, but we have subarray. Okay, part bytes subarray. We skip 5 bytes for the sync. Then we have file name 512. That's 17. Decode file name. Bytes and file name, and we need to skip another. It's like 17, 21 bytes subarray 21. I think this will store the file. Okay. I think this should download the file immediately. Let's try again. Connect. Didn't download. What happened? Yeah, we have an error. Promise bytes not found. Data. It's data, not white bytes. I just copied like a stupid person here. Okay. Clicked the Oh, it filled the file name with underscores. That's not good. How do we? Okay. Remove trailing zeros from byte array.js. Okay. ChatGPT just figures that out for me. Okay. Trim trailing. So how does it has a sync signal. I record like 2 bytes of complete silence, and if there is like 4 sync bytes, which are basically the word sync, if they come directly after a silence, then we have a start of a new block. So it basically, even if there is a file with the word sync in it, there is never silence in front of that. So that's always the start of the block. That's how I detect it. And basically that was also the last thing that I implemented, is to detect if there is a silence, and the silence should be like a few samples ago, like samples per word, whatever. And this is how it detects that. But it's very tuned. Everything is very tuned. Look at the constants here. This is some of the values like silence level and sync power threshold are empirically determined. All right, let's continue with that. Let's try again. Didn't work. Can't find file. Something happened. What is it with the stream? Or it's the new environment with the closed case. It's reading a long file. Maybe it found. No. Maybe it found. Yeah. It rewinds automatically, but it might fail at some point. So maybe it downloads Pac-Man right now. Because usually it would go out of sync and. So if we are lucky. Oh! Wait. Did it download the complete file? Yes! Oh, we found Pac-Man. It was the second file on the tape. Okay, wait. Now, let me put a new folder here. Okay, I need to record this. New folder. We downloaded it from there. Here. And hey, Kaspar! What? Kaspar! What? Thank you very much. This is way too much. What? Are you crazy? Some people pay that much rent a month. Wow, thank you very much. That's very generous. That's crazy. That's I'm sweating. I'm sweating. Insta sweating. Look at that. Look at that. I'm sweating. We are getting closer here. This is crazy. Kaspar 500. That's 117.15. Thank you very much. That's crazy. Wow, I'm stunned. Really. Yeah, let's try to load the cartridge. Okay, C64 test. Oh no, that's tape image. Sorry. Cartridge image here. C64 test. Let's see if it loads. It loads! Wait, let's turn on desktop audio. Does it work? It works! This is the first thing that I ever loaded from tape.
Waka, waka, waka.
Yeah!
Yeah.
Oh wow. Annoying sounds. Uh-oh. Uh-oh.
Cheers.
Awesome.
RP 2040C64 emulator più this device.
I never played Pac-Man before, like this original Atari version. Okay, perfect. Okay.
Annoying.
Enough.
I know.
What? Dan, thank you very much. Okay, this is all recorded. Peeps, you're crazy filling my excavator fund. You're crazy. We will. Okay. That's 20 Canadian. $12.47. What is going on, people? Thank you very much. Yeah, it's unfortunately dollar amount is bad. Because of the current US politics, I'm earning everything in dollar. I lost in the past 3 months, I lost like $1,000 in conversion from dollar to euro compared to before. So yeah, not that great. Anyways, file downloader works. We have 2 files stored. Okay, let's rewind and try again. This is so crazy. It just worked. Lost. Yeah, sponsors AdSense space. Yeah. It's so sad. I thought, like, also from YouTube, from my last good video, I thought I would get like $3,000 and then it ended up being 2,600. Still TXT. No. It didn't cut off the trailing zeros. Why is this file name? No. What we want, yeah, it's, huh? Why is this? Didn't cut off the trailing zeros. Let's debug that. We want it to appear as a mass storage device, and then just loading everything, like the whole. Foo! What is 40,000? What is 40,000? What is 40,000? Is this like a full salary? 852. Am I right? Not as oh, crazy. 852. How much are we? What? We are collected $500 already. This is like 10% almost. Look at that. Look at that. I'm wondering if I should risk to buy one from China for 3,000 instead one from the hardware store for 5,000. Anyways, I anything that YouTube takes, I fill that up. Import taxes. Oh, yeah. We wanted to debug that. Okay, let's debug. Aldi online shop. What? Are you crazy? Aldi? Is it Scheppach or Männerspielzeug? Is this the zipper? Einen ähnlichen Bagger, Männerspielzeug. Yeah, they hit the PayPal gives me like 100% almost bad conversion ratio. So if you have like spare euros, then I don't lose on the conversion. The conversion is about 5%. Wait. Let's look on Aldi Bagger. Benzin Scheppach. Yeah, it's the Scheppach one. It doesn't come with the accessories, but it's slightly less expensive than elsewhere. Like we can save up $100. Cool mirrors, yeah. Wise, yeah. But Wise takes also like conversion. Zuzüglich Versand. Yeah, oh no. Yeah, this is the worst. I think Hornbach. I have new pictures. I was at Hornbach this weekend. What? You 3D printed. Yeah, I saw one for 50. You can buy for 50 or $60. You can buy a toy that works like a regular excavator. Bagger. Here, zipper. Oh, they have new versions. What can I? Blick? What is Blick? Never heard for that. What is Blick? Blick. Ah. Okay, I will do until next time. Oh no, I would just take I would add or try to get the accessory for like the claw here, so you can pick up stones with the claw without needing to like. Yeah, the thumb. Yes, that's what I would try to get that or make one myself. Okay. But where do you get one? Where do you the we you know what we do? Then you know what we do? We take this one, then swap this to here, and drill a hole here and put the cylinder in this hole and here. Then we have inversed it. Easy peasy. This one is Verkauf. Markt abholen. Oh yeah, 40 bucks is shipping. Shipping is 40 bucks. I will certainly let it ship. If I buy that one, who knows. Anyways, let's continue. Reading files. What? Princess local store, and then you with 2 kilometers per hour you drive back to your home. Oh yeah, 10k. Wow. Special order. Is this Canadian? That's not that expensive then. That's not. Oh, that's also. Thank you for the follow. That's also one with the cylinder in the front, even without the protective cover for the cylinder. Here. $5 Canadian. Huh? What? Okay. Oh yeah, I wanted to show you the latest Chinese one. I'm really I'm tempted. As soon as we are in the ballpark of Chinese excavator, I will try to check if we can get one from China, but in the end it might be in trouble because Zipper is an Austrian company. Sponsorship? Nah. I really can't do this again. Zipper. You can reach out for me in my name. Bitluni wants a zipper. It's an Austrian company. Where are my pictures? The latest one here. Oh yeah, wait. I will store them. Here, so I can access them from my PC. Oh no. Did I dox everything? Damn it. Now I need to check what I doxed here. As always. Yeah, it wasn't. There were no naked selfies. I'm out of this. There is nothing there. I don't think so. There is nothing. There is nothing. Yeah. Huh? I want the stupid photos. Telegram is annoying! Ah! Here we go. Here. This is Tony. on the excavator. This one is green. What is this? What is this face? I need I need this. Yeah. Or I am a big person, who knows? Here's another one. Wait. Wait, I need a full resolution of those. I love it. Oh wait, I have even more pictures. More pictures, more faces. They're uploading. Uploading. This is the service for the support. Let me get the full resolution here. Okay. Ah! Is this troll face? Look at this. This is hilarious. Here's another one. The faces. Here. Oh, there's a dude in the background. Uh-oh. Privacy violation. More faces. People who wants to the things to get done. All right. But the troll face one is hilarious. I need to. Hey Adam. Okay. So we can store. Wait, wrong here. I close Telegram before it docks even more for today. Here we can store and load files by the controls. Yeah. We proved that we can store files. We can store even a bigger file, but I don't know how to control some of the games. What else do we have? We can try to store. Wait, there is a Star Wars Atari version. Let me make this a small file. Star Wars CRT. Okay, let's store that on our device. Okay, here we go. Oh. Huh? What's going on? Oh, wait, this is wrong. Okay. Yeah. It's Star Wars cartridge and it's uploading 17 kilobytes. So this will take 2 minutes roundabout. How much can we store on one tape of 60 minutes? Play speed is like double the play speed, so I would say 30 minutes is 30 times 8 kilobytes is a lot, like 250 kilobytes on one side of a tape. Let's wait. I have no CRC checking yet. How did the weather do? Oh yeah. Some tea. I would drink also some tea if I didn't have the booster. I bought 2 new tea types. It's not proper tea, like pretentious super tea. It's only peppermint, and I got like orange tea or something. I found a Chinese excavator company that says they have a European warehouse. What? Then show me, tell me, which one is it? Tell me. But they probably sell at the same price. Can still hear it writing. Oh, it recorded. It's rewinding. %? That would be cool. Okay. Okay, to be sure, I refresh the page. Okay, let's start. Read from tape. It's reading. That will take 2 minutes. Oh, we can stop the time. What is it? Yeah. So at 53 more or less. Uh, 30 seconds. We can try to increase the speed. Like I could try 1.2 kilohertz. So we can increase by 20% or something. But I had dropouts at 1.5 at every 256 bytes more or less. Okay, here we go. Should be done any second now. Here we go. Waiting time more colorful. Still reading. Let's calculate. 1000 bits. Second times 60. Oh, it's done. Okay, did it download the file? It downloaded the file. Let's scroll down. Okay. I have no clue if this is correct at the end. It looks like can't tell. Let's see if we can load it. Oh, I clipped. I clipped the file name. CRT. Yeah, it should be that. Yeah. Let's move it into our C64 test. Yes, it rewinds even. We can still manually rewind, but oh, it didn't rewind. Okay, now it rewinds. Okay, let's try to load the cartridge. Attach cartridge. Here. Let's see if we get anything. Nah. Failure. Failure is an option. Then load. Okay.
Perhaps the reset helps?
Star Wars. Let's try again. Nope. Okay. Let's try the original one. Oh, the original one works. Oh, we have the first failure. The first failure. We could compare the files. Could compare the files. Let me do the comparison here. Oh no, that's the wrong. I can see it. Enhance speed? Oh, here. There is a flipped byte. What do we have here? Oh, here is a flipped byte. Where is it in the first one? Oh, we have several bytes here. 18, this one here. No, we have some errors here. All right. Let's upload again. I will rename it as well. And then let's upload it again and see if we can fix our mistakes. No CRC. Command line FC file compare B. Okay, we can try that. Hey Markus Karkas. Alright. Let's reset everything. Can't hear anything uploading. Oh. Did we connect? Huh? Huh? It's not reacting? Okay, let's restart. Okay, let's try again. Okay, now it's recording again. Strange that the errors were like in the first few bytes. I really don't want to slow down. Yeah, that's a C64. C64 cartridge. 16 kilobytes might be too much for it. We can compare files, file compare. Okay. Oh, it's done. Yeah, that's why. What was the syntax? Oh, B. Okay. B file 1, file 2. File close. Okay. Okay, let's try a reconnect. Or so. Oops. Oh. Ah! 4 bytes. Damn it. Damn it. 4 bytes out of 16 kilobytes. But it's a good test. We are reading back, and now yeah, and it's made it stop working. The 18th byte. Oh no, this 24th byte probably was the issue. It's reading 2 minutes. Here we go. It downloaded. It downloaded. Okay. Here. Bloop. Let's try again. Let's try again. Oh! Oh wait, it's too small. It failed. It failed. It failed. No, it failed to read. Or 12 kilobytes. Too many zeros here. It fit. Let me read again. Yeah. Need to read again. Nope. It cancels. Doesn't look good. Uh-oh. Alright, peeps. I need to... Let's reset. You can try a lower bitrate, but or we can try 2 samples per 2 waves per bit. That would be still half the bitrate. Even if we increase it, it's not great. It's probably very noisy now in the... What was stored that odd numbers and you get error checking. Yeah. What we can do, we can store it in chunks, put an CSC there, and if we fail to read a chunk, we try again until we read all chunks correctly. How about that? What is the default sampling rate of the device on the C64 without fast load? Wait, that's the wrong one. Yeah. Here we are at frequency 1000. Can't go slower. This will take ages. We can try go slower. Still reading back. Here we go. Nah, it failed. Okay, we try 800 then. Oh yeah, whatever. Okay. Oh, we need to. No! Oh, stop. Fuck. We can cancel. Do you intend to doing FPGA streams? I'd be interested in FPGA. 9 grams staff, 9G, 10G. File not found. I will do FPGA eventually, but that might take a while. I don't know when the next project will be. Let's try again. Star Wars, the cartridge of Doom, 800 kilobits. We dropped another 20%. This will take for ages. Hey Christian, is reading Solomon the one where they place the data in the XY grid and have additional parity bits over each axis? Error correction. We could store like, I don't know what is. Store several extra bits to fix one broken bit per byte. What is this? Let me check. Correction. At some point it might be just good to store it twice. All right. It's stored. It's rewinding now. Here we go. Doom not fit. Yeah, if you have Doom on C64, give me, I will... let's read it. File not found. What? Oh, the silence code might interfere. Yeah. Let me remove that. I didn't test it with different frequencies. Silence levels. Can just remove that. Nope. Didn't work at all. What? Now nothing works. Perfect. Let's try Pac-Man again. A smaller image, and we try at 1.2 kilobits per second. Unexpected feature detected. Grocery Chris. Okay. So this cartridge is cursed. Marcus Carcas, what are you? Oh no. Am I doxing again? No. Wait a second. Ah. Huh? Marcus, that's Doom. But what do I do with those images? How do I open that? Super CPU V2 and 60 megabytes of RAM. What? No. What is this? 16 kilobytes. What is the program? Probably disk files or something. Okay, file. Smart attach. What is smart attach? Is this like oh, are those disks? Vad loader. File not found error. Okay. Yeah, unfortunately that's too big. Alright, where were we? We were here. Read from tape. One 1.2 kilobits per second. Oh! No. That failed as well. I'm wondering if I can add some shielding to protect it from read errors. I don't think the tape is worn. I used it only today, so several writes, rewrites. Strange. We should try maybe. I never tried it before. 2 waves per. Two waves per bit. I have no clue if this code works. With that, it might completely fail. So we can try higher frequency and then get like 750 kilobits per second. But more reliable. Okay. Let's try with test first. Where is it? Test. Nope. Doesn't work. Oh! It didn't start at the right spot. It's really strange. How did it find the sync? What? It was able to decode. No, file not found. Wait. No. Okay, it didn't. No, it didn't work. It didn't work. Didn't work at all. It tries 10 seconds. If it shows file not found, this is just old crap from the file. Nope. That doesn't work. Oops. Did they change? Zero. I need to find the issue with that. Or I tried a different tape. We just get a different tape. Uh-oh. I think it's in an error state at the moment. Check if there is something. Let's try again. I think we should try yeah, it's working. It's strange since I put it in the case, probably there is so much noise in the case that I might need to put some shielding in there, like maybe aluminum tape or something in between the PCBs, so we get... Hey, Fu, thank you very much. Yet... Oh, you mean damaged tape? Okay. Oh, the tape is wrong way around. Thank you, Fu. Where is my excavator fund window? What is it? This is 85, 152, 160, once, oh, 4,000, 8,000, 160, 170. Here we go. Thank you, Fu. It's all maintained here. It's rewinding. The tape was the wrong way around. Okay. I need a method to store the individual chunks. So I will probably 150. Wow, highest frequency so far. Braided. I could do that with ground wire as well, but I don't want to take it apart for now. Wondering if I could just tweak the code for it to work, but I would rather split the data into chunks and then read back the chunks with a CRC, and if the CRC is of one chunk is broken or whatever, we... Hey, Graustreif! If a CRC is broken, then we just reload the chunk. Alright. Here we go, drop file here, test. Let's try again. Oh, it's not connected. Is it broken? Is it open somewhere else? Oh. I pressed read tape. Is it reading? I hope not. Oh no! What did I do again? Connection is refused. Oh, it's bugging out completely. Okay, now it's recording. Hey, Infinite Cola. Ah, damn it. Yeah, you're right at the right time for the dataset, but this tape somewhat doesn't work. I think it's, I don't know if it's the tape. Something is wrong here. Let me. I can't even open it. Yeah, I think it's an error state. Might be blocked or something. What's with this tape? Okay, rewinding again. Wait! No. I fool. I thought you donated again. Please. Please give me a break. Vinyl records. Oh, that's a good thing. We could. Why not? But how do we? How do? Risky. I have vinyl player, but how do you record on a vinyl? Need to scratch it. Graustreif, yes, mini bagger are in common. That's the latest shit. We already collected 500. It's now. I had the tape wrong way around. I don't know. It was strange behavior. Oh, you know what? Might be something physically blocking if it's trying to read from the second side automatically. It's rewinding right now. All right. I will try to we have ChatGPT. I think I made where is it? Core character value validate. Here is the code for CRC 16. So encode as what is test H? All right. Okay. CRC16. That's alright. We can add this to the main, I think. Or we should do chunks here. Store in chunks. Or you yeah, file system, whatever. Oh, what am I doing? Or is it without H? No. Okay, so file system, we have one function. Yeah, void store uint data hey, that's maker size store file or store data. Now we will have chunks. So size void store chunk number chunk number data size. So we can store chunks, then what should we store? We store things to store. Things to store will be sync signal. Then we have chunk number, total chunks or Yeah, I know. They are right, but none of these are right protected here. Chunk number. Do we store total chunks? Data. Const x bytes per chunk. That will be, yeah, whatever. Let's do 256 or 512. We can do smaller chunks and faster bitrate, but it might take a while to read multiple times if we have errors. Yeah, let's do that. So we can maybe store a complete file system. We could display what chunks are already loaded if we send a status. Chunk number, size. The weight of the excavator, 500 kilos. Yeah. Is the CRC initial value is a complicated way to calculate it. We could start with the initial value here, so we can concatenate stuff. Okay, here we go. So if we have like everything stored, then we can just continue using the CRC in the next chunk. So this will be easy. Validate, right. CRC, so we can put everything included in CRC. This will be everything is included in CRC. This will be basically that. data size total chunks. I just do total chunks so we have more or less an estimate, and we can stop once we read all the chunks. Can we read fast enough though? We need to store data. We need to have a break of at least 1 second to compare and store the CRC and so on. So store chunk we don't need that part. I think we can do everything here. Things to store. Sync signal. Sync signal is handled by this now record samples, encode packet, yeah, encode packet, that's it. Okay, records, this is outside our scope. Duck enable, basically we will replace this part here. Okay, so this will be store data. Chunks is basically size divided by bytes per chunk. Size plus bytes per chunk minus 1. That's the number of chunks. And bytes per chunk, no, bytes stored chunk total bytes stored. Chunk number starts at 0. And then we do the following. Number of chunks things to store, sync signal. 4 chunks, number of chunks. I don't think that's the way to leave it like that. Number of chunks I plus plus. Then we have encode packet. Chunk size. And 16T. Chunk size is basically bytes per chunk. Oops. If I equals -1, then let's remove that. Then we store size minus total bytes stored, otherwise bytes per chunk. Okay, so this is what we store. So last chunk will have only the remaining bytes, and then we have encode packet. The encode packet we have extra data here. Damn it. Should we overthink or not? Hey Faction. I'm trying to code a new storage method for our micro data set that you can see here. It's a microcassette storage comparable to the C64 original one, which is a little bit bigger. And what we did so far is store and load files again, but with bigger files we have like at 16 kilobytes we had like 4 wrong bytes. So I want to store the files in chunks, and now I'm trying to chunk up the files. Maybe I will add here a header. So let me do this, encode packet, and we will just add a header. Header. Header size TCRC. Okay, so this is now more complicated, but this is sync bytes. Then we will encode the actual bytes. So we will encode B, that's header size. Header size and header. Ticks per wave. And then we will do oops. Actual bytes and then CRC. CRC. That should calculate the CRC on its own. Okay. Let's encode bytes. CRC 55 little endian. CRC. Okay, so that stores header first, then data and sync signal. Okay, so encode packet is now changed in the main. Encode packet 0, no header. You know what? I put it on the back and no CRC. CRC will be just 0. So basically I don't need to change it. Kenny, thank you for the follow. Where is my test timer? There. Okay, let's change the order here. So this is always optional. Zero, 0 and 0. No, FFF, that's the CRC for 0. Okay. Length of file. That's on another layer. That's added already by I don't know. Is it rewinded? Let me store the file again, and then we can. Okay. Let me read it. We could try to determine, but the problem is, oh, it didn't work. Doesn't read. Doesn't read. Times out, I believe. Still reads. Huh? It should time out after 10 seconds. I don't know what it's reading. It's reading something. Data size headers here. CRC. Okay. So encode packet file length. Then we need so what's happening about this file size and everything that's stored within the data that we get in here. So file name and everything is stored already here. We chunk up the whole thing, including the file name. Is it did it crash or something? What is it reading? It's reading a huge file. I don't know what file it's reading. Or it crashed. Okay, chunk number. Header 3. Header 0 is chunk number or size. Chunks. It's the chunk number. Then total chunks, number of chunks. Header 3 is the data size, so chunk size. Then the CRC16 equals, oh, data is basically data and then total bytes stored. That will be the address. Then we need chunk size. Oh, wait a second. Do we CRC? How do we know the chunk size? If there is an error there. doesn't need to CRC that, because if that's broken, you know what, let's start with just CRCing everything here. So chunk size without the header, chunk size encode packet. Okay, so header six bytes, and then CRC. Then we do delay root timer, like 1 second in between each chunk. Oh, that's a lot. $200 milliseconds. Should that be enough to? Oh, yeah, I need also encode frequency. So frequency and encode packet is basically chunk size, and then we need to chunk size. We don't need to wait extra if oops. Okay, so if it's not the last chunk, we do that. But we could add silence at the end, actually. You know what? I want the silence at the end. So we are sure that encode packet is basically include oh, that's already it for storing the data in chunks. Encoders. End of file. Yeah, that's done with number of chunks here and chunk ID. Each chunk knows what the total chunk amount is. Now we need to load the data. We need to buffer end of file name. I don't what you want. Okay. Void restore data or load data. We have maintain running sums running the code. Wow, the method got long. Error correction. Yeah, but it's a huge overhead. Compression, yeah. Frequency decoder. Ah. Store data, code frequency, qubits. You don't store in qubits, you entangle. Alright. It's so hot in here. I think the rain stopped. I can open the window. Oh yeah, some fresh air. Actually, that should do it. Decode packets. Packet found. Okay. Not this one. The big one doesn't have one, but it doesn't matter. Yeah, whatever. Packet found. Load data. Sample buffer size. Timeout, that's alright. We just copied the header. Oh, you're right, here's a bug. The first one. I have another window with screen. Maybe I open that one. Oh yeah, fresh air. Decode packets. Store data, load data. Okay, that's bool. What we need is timeout. How does it complete? Oh yeah. There you go. Here we go. Uint 8t chunk buffer is basically bytes per chunk plus sync bytes count plus oh, I think it crashed. The tape just stopped. I think the microcontroller crashed out. Sync byte count 6. No, not sync byte count. What did I do? Header byte count. Plus the byte count. CRC byte count is basically here. Oopsies. Okay. Oops. So this is what I expect the most. This is all the data. Sync by header, whatever. This is the chunk buffer. So we will load. Oops. We will rewind. Oh no, wait. Timeout. Chunk. We need some extra chunk data here. Load data. Let me do that. Load data. Chunk buffer. Huh? Why doesn't chunk buffer size? Size is this here. Code frequency, chunk buffer size, coded so timeout is here. Then we have chunk. We need to check CRC. So if packet found, you know what? If we didn't find any packet, then we didn't packet found, return false. Didn't do anything. Okay. Otherwise, we analyze the data. So int 16t header equals t chunk buffer. We skip 4 bytes for, oh no, we skip sync byte count. Let's do it correctly. That's the header. CRC. Hey Christopher. Bool. Packet okay. True. If decoded bytes shorter than what is it? Sync byte count plus not chunk buffer size, header byte count plus CRC byte count. Skip packet okay false. Okay, now let's decode the header. Int chunk var equals chunk number equals header 0. It's the first thing that we store, the number of chunks, total chunks. of chunks number of chunks and chunk, what was it? Chunk size header if the coded bytes plus chunk size then false. Okay, so not enough data, not enough data as well. Then also if chunk number is greater than number of chunks greater equal number of chunks and broken. Okay, so these are the error states. Otherwise we compare the CRC 49. No, because this is a return parameter. Here, decoded bytes, it's a return value. All right. Now we can calculate and 16t check CRC yes, there will be a continue or something. Not sure yet. We need to skip and read the next chunk. So what we can do, our to-do list might be, I would need like a to-do list, but we need to try read one chunk, test that. Store a file with a chunk, then read it back, check if the CRC works, everything. Then store a file with multiple chunks, try to read the first chunk, and then multiple chunks and see which chunks fail, and then maybe even like get this debug information to we can debug the device though after it's done reading. Then we need to do a loop around that, try to read again and again which chunk is junk. If we have junky chunks, then we try to read again and until we fix that. What's Lonnie cooking? Nishay. We are trying to chunk up the files that we store on our tape. It worked somehow. I was able to, even I have it on camera, store and restore the cartridge with Pac-Man. So C64 cartridge. Yes, we will rewind, wait for, I don't know, a certain amount of time, and then or if we have, let's say we store a file system with we have like 50 kilobytes of memory. We could read, like store basically a disk of 50 kilobytes, and then let's say we emulate a mass storage device. Then it would rewind to refetch misread data. Yes, that's what we want to do. Like read the chunks again and then check again if we can fix the chunks. Yeah, so if we like we can store like certain amount of sectors that we can cache in the SRAM of the microcontroller. So if we drop a file on there, it will be written to the SRAM, and if there is like a timeout which has no file operation on the mass storage device, then it will rewind and write the whole SRAM to the tape multiple times. So let's say we have like we store like 50 kilobytes. We can store it probably 5 times on one side of the tape, which is half an hour. You can just let it store. Do we interrupt it? I'm not sure if we can. We should interrupt it. Majority wins. Yeah, and then it will just, we will store like multiple copies of it, and read all the copies until all the chunks are correct. That might be like 2 copies in the end, or first copy if we are lucky. Something like that, but this is like, ooh, a lot of work. Decoded size. Okay, now let's get back to that. Wait, what I'm doing here? File system. Okay, CRC. So we have external redundancy. Yeah, we store in the flash of the microcontroller and fake it. Nah. I mean, we can cache it. How do we? If there is a connection loss, we would need like a button to store everything. Or I just time out like 1 minute or something. If it's changed. Or we can just change the sectors that are rewritten, like the fat table. CRC 16. Okay, now we need sync byte counts. Oh shoot, that is difficult. Wait, there's this missing. Or this. Doesn't matter. That would be a serious mistake, actually, this cast. Sync byte count plus header byte count. CRC. No. Chunk size. Oops. Chunk size. Here we go. If CRC then we have CRC failed. Hey, Fiddlewissen, thank you for the raid. Hello everyone. Wow, 11 people. What a cool thing. So Silly Philly, hello. So people want to know what's happening here on this stream, probably. Are you ready? Okay, so I'm making this mass storage device that uses microcassettes to basically simulate what this original one does, which is way bigger. And what we got so far is over web serial, we're able to store and restore files, but they're sometimes broken. Recently quite often broken, I don't know why. Yeah, but we were already capable of loading a C64 ROM with Pac-Man successfully from the tape. And store and restore it from the tape. Now I want to chunk up the data on the tape and check for errors so we can reread the chunks that failed and reload the data. So it's a lot of coding right now, and I hope we will be able to like complete something that we can test. Show us. Oh, yeah. At the moment, I don't think we will be able to load this thing. Let me try to connect if it's even connect. Nah, the MCU crashed. I don't know. Probably it's a power error or something. Now it's connected. Okay, I need to rewind. That takes a while because it crashed while reading. I can try to load the file once it's rewound. Okay, CRC failed. How do we skip all that stuff here? How can we check for packet? Okay. Okay, I would try to. Oh, hey Sean, thank you very much. I'm trying to make a new unique thing again. Chunk one. No, it's stored its number, so that should be good enough. Let me skip over stuff that, you know what, we can do. Can do a break here. Break. I don't want like a go-to thing or nest a lot of break and do basically switch. Dirty trick. Switch case. So I can break from each of those. Now we need packet OK to be external here. This is mean. I could do while for. Yeah, we can also do for. Instead of that, we can do for. Okay, so now after that we check if packet is okay. Packet is okay. Then mark packet as red and copy the data. Chunk size. So copy data. Copy data. Chunk file. We need timeout decoded bytes here. Let's do chunk states and max chunks. Chunks, okay. Decoded by why is it complaining here though? Data timeout, okay. Then also we need chunk number of chunks. Okay, we have if number of chunks. You know what? Or we just load if chunk number is greater equal max chunks. We just clip the file if it's too big for this microcontroller. Max chunks, then packet okay is false and break. clipped chunks marked. Okay, copy data, then do for oopla chunk bytes per chunk, chunk offset is basically need to predefine that. Oh, yeah. Decoded bytes, but what does it do? Decoded. Oh, chunk buffer. It's not compatible. What did I do wrong? Oh yeah. Chunk. Oh, wait a second, that's the wrong. Why did I replace it? Decode packet. Here we go. Oh. Okay. Let's do 0 as well. Bytes per chunk times chunk number. And we have decoded buffer, offset, chunk offset plus I, and then we do that plus I. Okay, we copy that, then we mark mark the chunk else. So we have the opportunity to mark a chunk that we found it, but we didn't succeed to read it. So first of all, yeah, we mark that chunk, wait, here, chunk states chunk number 1, which is okay. 3's error, 0 not available or something. So else if chunk number equals 0, then we have found it, but we didn't read it. So let's change it to we can also skip that one if skip the chunk, don't do anything if it's okay already. So we can send the states of the chunks to the web serial to show the progress of the reading. Like defrag back in the time, back in the 90s or early 2000s. If not equal, red turbo type stripes. Okay. So you know what? Decode packet, it's still running. CRC failed. Yeah. Packet. Yeah, that's I never had a C64. My age. 52 legs brackets. Yeah, it's not great. Packet not found. I think 10 seconds of silence is basically done at this point. I will leave it there. You will fire me if I don't put brackets there. Okay, might be just the end of the thing. Battery backed rank cartridges? Probably. Yeah, that's what we are doing here. Chunk states. And what we also need is basically if chunk number equals no not max chunks, number of chunks minus 1. Good night, Kaspar. Thank you very much for the generous donation, really. Your name will be very prominent on the boo. Okay, I would say we don't need return false. There is no data. Or you know what? Bool found at least one chunk. One chunk. So we don't need to check anything. Found at least one chunk, and then we have packet. Okay, found at least one chunk. True. Anything else is probably garbage data. Why did I call it packet okay? It should be chunk okay. Okay, so then maybe also we have a max loading time. But I don't want to. Let's do this. while 1. It will load until it doesn't find anything anymore for 10 seconds. Return. False. I know how, why. Okay, we can do this, whatever. Now we need to fix load data, sample buffer size, how many chunks can we store? 5 or 1,000? As a 256 chunks, or maybe no, 50 kilobytes, 512 chunk data. Right. Chunk states. We can do a global variable here. Sample buffer. Chunk states. Um, 512. It's basically 100. Let's do. Okay, let's do 100. I don't care. 100 chunks. Chunk states, max chunks. Load data, chunk states, max chunk count, chunk found. Okay, we can do the following. Oh, this will be interesting. Load data. Decoded data size. Decoded data size. I think decoded bytes. Oh, yeah. Data size. Okay, so data size will be determined by basically after each chunk, if chunk okay, data size is basically total number of chunks at least number of chunks. Oh wait, the last chunk. Maybe. Oh, I have an idea. How about the last written byte? So we do this. Last written byte. And then we just change it. Here. Last written byte. Oh, that's not last written byte. That's oh, that's how do we call it? That might be number chunk offset plus bytes. Not bytes per chunk. What is it? That's wrong. Chunk size is the correct thing. Chunk size. Huh? Was it last written? Okay, here. So, decoded size. Packet found. This is not written back anymore. Okay. Oh, by the way, we can try to write something. I completely forgot that we wanted to write a test. I didn't compile anything yet, so... Oh. It crashed again. It's strange. Wait. Was it just not connected? Oh, okay. I think there's power issue because I think it's reset again. No, it's an error state. Okay, I tried a different tape. Somehow we were not lucky with this one. think I need to take it apart again because it's somehow yeah, no, it's crashed. It's either the USB power is low. Yeah, it's in an error state. Okay, I will take it apart. Let me disassemble the device again. Oh. Where is here? We can find out if it's something physical. It feels like okay, let me disassemble it like that. Let's plug it in again and see if we get anything. Oh. Oh yeah, power. I just broke the wire. Damn it. Was it maybe shown already a little bit? Okay, let me fix that. The soldering iron. Little touch up. They are too stiff. The wires here are too stiff. It's the 5-volt power here. It heat up first. Yeah. I might even replace it with enameled wires as well. These ones are not that great. Okay. Or silicon wires. Okay. Let's try again. Let's drop the file. Oh. Now it's done. Okay. Read file from tape. Reading back didn't work. 10 seconds. It crashed. Huh? What did we do that it crashed now? Yeah, I hope I can release it on this weekend. Damn it. I think the interface crashed. Yeah. Let me check the changes. Waves per bit 0. What? Oh no, peeps. This can never work. And we are wondering why everything fails. It's probably compiled already, so okay. Oh wait, chunk buffer. What? What problems do we have? Unused chunk number. Oh yeah, chunk number. Store data. Yeah, we don't need that, but let's try reconnect. Rewind. That takes a while. Oh wait. I changed something in the main. It wouldn't show the data correctly. Wait, right. I need to revert that. But we can already store it correctly. Okay, so let's store the data, the test. Okay, just the restore wouldn't work. Let me check main. Frequency 1500. Chunk found. Yeah. Packet found. I just Okay. Oh no, store data. Oh, it used a new function. Okay. We might want to revert to the version. Okay, here packet found and then encode packet. Okay. Otherwise we will have like a strange chunk. But we could read from tape. We can see what kind of chunk data it's stored. If it's stored anything. Oh no, it's reading. And reading and reading and reading. Did it crash? No, it didn't crash. File not found. Yeah, that's what I think. Let's store again. Old method. And the rewinds. Okay. It downloaded the file successfully, bitluni was here, you it works. Okay. And FF is the CRC! Alright. So if we don't store the CRC, okay, this old method still works. Now we want to store the new data. What we want to do, okay, we want to see what kind of data we got there. Decode data log clear. We always do this. We just show the data, but we don't make a download link. Okay, so yeah, we need to upload that. We will see the raw chunk data that we were able to store or whatever. Okay, reload here. Did we rewind? I hope so. And we can just store something bigger. Now let's do test, whatever. Okay. Okay, what did we get? We get the state that was okay. Sync. Then we have after sync we have this is the number, chunk number, total chunks, the size of the chunk, and then the data, which is basically the file name, the size of the file, and everything. And then after that it works, we have the CRC. Now we can try to load it with our new stuff. We are not finished yet here. Close that. We don't do decode packet. Chunk found. Now the issue is chunk state. We don't know how many chunks there are. Data size. You can see it's too many. I just add a break here. Timeout decoded size. How did we call it? Max chunks. Number of chunks. And number of chunks. Wait. No. We need to rename it last chunk. Chunk count. Let's do here. Chunk okay. Chunk count. Number of chunks. Okay, here we go. So we have some sort indication how many chunks we got there. Okay, so packet found, we don't do this anymore. We can just write one here. Instead. And see found packet indicator. Funny. Data size. Total size. Just one. Okay. Sample decoded data size. Okay. We can also write write the chunk file. So we do write let's do two chunk states. Then we write how many chunks it is. Serial write chunk count. Then do for chunk count total size. I don't need that indicator anymore actually. But I will write the indicator that we found the chunk, the file here. This is the file. Serial write 1. File data. And if no chunks found, if no chunks were found, then we can break also. Basically this will be the error state. No chunks found will be just 0. Rewind as well. Zero, and this will be chunk states, file data. What did it do? Okay, we need to fix that. Decode data. Oh no. This one reads. That's when we read the whole file. Damn it. When do we start? When do we end? Hmm. Do we need a read loop? Hey daddy. Yeah, we're trying to fix my file storage, microcassette file storage, storing files in chunks. Yeah, it's disassembled now, but it's basically storing data on those cassettes here. And now I need to find a way. Oh, I need a read loop. Then I think I have a read loop somewhere here. Test should be a read loop. Yeah. We need to re-instantiate the read loop. Not read data. Await reader writer and then a read loop here. Oh wow. Where's the read loop? I mean, it's okay, but rubber ducky. Yeah. Read data. Okay. The formatting spaces. Who the I hate spaces here. Okay, now it's more readable. It's not plots anymore. We're done value. Okay, so instead of read data and then expected length, copy data into payload, we will always read it and try to get data on the fly. So value length, then we will do the following. So what is the state? The current state let state or waiting for command true. So let's do that. If waiting for command, then switch value or we do and equals -1, then we have you know what, idle should be 0. Let's do it. and then the command will be instantly idle if we have an error state. If not command, then basically command value Johnny will be mad if I don't do bracket C. Else then we just switch the command. Switch command. Wait, where is this from? The while needs an indentation here. Almost. We will attach the bytes, so we will basically command and then payload, let payload be empty. Yeah. Switch, yeah. Wait, core case 1 break. What is case 1? Case 1 is in our test. Where's the main? Here. Chunk states, file data. Okay, file data. Check if interpret file data and then value not value, sorry, we need to attach payload or packets, payload push value I. So we have received the command value, then we add new byte, interpret value. If it's interpret, then command and 0 and then payload. Oh wait, done. Then we do the following: if done, it's like a British done. If done, then we do command equals 0 and payload equals, so the packet is done in that case. And we can do also 2, that will be chunk data. Data interpret chunk data case 0 default case. And done needs to be false. Flaws. False. Okay. So we have rewritten this a little bit. Log data, decode data is basically, oh, can we save the file? I'm not sure if we can save the file when we interpret data. Decode data. Okay, let's do interpret file data. What is the reader? The buffer reader or something. Let me check. Not value. What did I do here? This is payload. Payload. Okay. Some index insects here. Header, wait. Little endian data view. Okay. Header buffer. Okay, so read data. Gibberish. Header buffer. We do what? So alright. Uint array data buffer. Wait, we need to payload const data equals new block. That's a lot of conversions here, but this doesn't need to be performant. Oh yeah, wait, this doesn't need that. Data view 0 true uint data buffer, that's size. Does the size include the bytes? I don't think so. If payload length -4 shorter than size, also if payload length is shorter than 4, then return false. John, you will be mad if I don't do extra spares here. Length -4, return false. Yeah, we can do this to stay consistent. You know what? We don't need to convert the first 4 times. Here we go. Oh yes, it is midnight. I don't think I will have a snack for now. I would need like something to drink. My booster is gone, but I think we are almost there. 1 more hour. Payload length, size, return true. Robot butler to get you drinks yet? No, not yet. That will be the fund after the excavator fund. Text decoder, render preview, file name decoder, download link. Okay, return true subarray. Wait, we don't need 4. Make download link 20. Okay, this is interpret file that. Okay, so we have the first one. Now we will do the second one. Interpret chunk data payload, and then we do chunk count. Data view, we don't need that. Size, payload 0, if payload length minus shorter, loaded chunk states states of chunks, chunk size const. Okay, for hex preview data, and anything else isn't needed. I think it's done. We need to upload this thing here. Okay. I think we don't need to re-record. Hey Sion, how was your stream yesterday? Uh-oh. It didn't stop. Oh, it stops after 10 seconds after the last chunk. It never stops. Ay, maybe we should debug. Foo. It's alright. That's cool. Okay, our stuff doesn't work as expected. I would need to debug it, or I remove the while loop here and only expect one chunk for now. Okay. Let's reconnect. Oh. Huh? Okay. Why did I hear? Let's rewind. Should we? RGB laser? Can you display now colorful stuff on your wall? Did it crash? Why does it load so long? Nice. What the f... Where is it stuck? It's somewhere stuck. It's an infinite loop or something. Okay. Oh. Return. Let me check what could be the issue here. Okay, we don't have an infinite loop. We decode the packet, it returns or breaks. What is the maximum? Decode buffer size. No, chunk buffer size. It should decode only a limited size and then timeout. I think it crashes. And since we have we should also disable the I interrupts. Should enable it when we try to debug. So chunk size. There is one check that we can do. Chunk size. Huh. That's false. Okay. Let's try it. Let's do the packet. You will see. There is, if we found the last chunk, it will just stop. But currently it would only read the first chunk since I removed the while loop. I'm wondering why. We connect? No. Okay, we connect and then I rewind. Take flag. Okay. Okay, buffer size decoded bytes 65. Okay, 10. Chunk number of chunks, chunk size. CRC. Wait a second. What happened here? It CRC 16 sync chunk size. Huh? It looks alright to me. Let's try again. Rewind. Okay, think byte. Why did it crash here? Okay, so we have CRC. I will just check again. It might not have crashed here. It might be like jumping over here because I mean it's some sort of F chunk. Okay, we can also break here. Oh. Wait, chunk not okay. Oh. What happened if chunk? I need to check where it crashed here. So let's do this. Hmm. Wait, what? Didn't break at all? Okay. Okay. Okay, packet found. Decoded buffers. Chunk number. Huh? Oh, this is the error. I have redefined those variables, damn it. Copy paste. Chunk size, yeah, I wanted to delete this, but it got lost in my stack somewhere. Yeah. Oh. I think I don't even need to debug it again. It will just work. How much did we lose? 15 minutes. This stupid bug. We should maybe no, it doesn't shout. It's not very sophisticated. Loud noises. Oh, it pronounces like each individual letter. Loud, Noisas is what it said. That's strange. Because it said loud correctly, but noises was like spelled individual letters. Interpret file text decoder. Render hex preview. You know what? Interpret chunk data. Interpret. I will do it here. Paused on exception. Oh, interesting. Yeah, it's not connecting right now because we are in the debugger. Are we? No, we are not. Oh, damn it. Where is it? Oh, here. Yeah, we are. Okay. Oh, yeah, I cut the flex Popo. I cut the PCB and soldered hair thin wires. As you can see, here here. Look at this mess. I don't know if you can see this. So it's just cut off and all these wires are soldered individually. 32 wires. Here, here's my diagram. Wait. With all the numberings. Simple electronics, yeah. Wait, where was I? Is it that? Damn it. Where did it go? Interface PC? Nah. It's only for fun. This is just, I mean, these recorders are so rare. You can't get them easily. I got like the only two in Germany from eBay. And this one is broken. So it's sometimes errors out. Alright, let me fix this stuff now. We want debugging. Okay, let's start again. I hope this time. Let's start. I have mini disc players, but the ones that support everything. Do you want to see the box with with all the components for the mini discs? Here. So, how do I show it? I'll do it this one here. Okay, so this was my one that I used in the 90s. Yeah, but the issue is because of DRMs you can't easily read back from digitally. So this one supports it with hacked firmware, but it's very cumbersome. It has USB and a special protocol. And the ones like high data mini disc players cost like $900 used if you want to buy them now. The Sony ones, they support random access on mini disc. This is what I would. This is crazy. You need to check eBay high data. Yeah, you need to check. Mini disc. Where's the high data MD player? What's the? There was a list. High MD MZRH1. MZRH1, I think it was this one. Yeah, here you go. You see that? Good luck with that. That's $1,000. Here. Wait a second. Power on untested. Yeah, but power on, what does that mean? Oh, we have some. Yeah, that's bidding. Yeah, $300 for a test. Okay. Okay, maybe we can get one for 600. Yeah, original box. This is only the box, not the contents. Beaten up one without accessories. I guess I could buy the device only without. So this is what you get if you want good stuff. I guess I will buy the excavator first before I continue with the high MD stuff or whatever. Where's my web serial interface? I mean, you can buy probably MD data storage. MD data, but they are also rare. What's going on here? Why don't I see USB? Drinks robot is cheaper. Yeah. Huh? Something's off. Aborted? What? Too many breakpoints. Ah. Okay. We have too many breakpoints. Here. Let's try again with fewer breakpoints. Micro CD isn't an MD drive. MD drive is magnetic optical drive. Oh, come on. Too many hardware. What? There are not many. There's only like... What's the count that we... Okay, let's do 2 breakpoints. Let's start again. If it complains again about too many breakpoints, command aborted. I think I need to reset the device or something. Restart editor. Yeah, it might be cached in the device itself. Yeah, now it works. It was the device. All right. Okay, connect to tape. Is it rewound? It was running for quite a long time, I would say. Still rewinding. I can hear it's almost done. is it doing? Is it rewinding the wrong direction? Let's hope not. Took the kind of rewind. Yeah. Okay, let's write it first. No. Okay, let's write it. Let's read it. Didn't break anywhere. Why not? Why don't you break? Where is it? Where is it situated? Failed. It's failed. Okay. Let's connect again. Does it break? Doesn't break. Do I really need to timeout. Okay, it didn't read anything. Yeah, right. Okay, let me run it without debugging, because that might be like an issue when I try to store stuff. Oh, also when I write data, I should maybe use interrupts, block interrupts as well. But let me just start. Let's try without debugging. Debugging is always bugging stuff. Okay, here we go. Ten seconds. Should stop also after 10 seconds. Or is it reading like a huge... No, it can't. 512 bytes maximum. Oh, damn it. Yeah, it probably crashed. Yeah. Why? Why me? Okay. Doesn't stop. Don't stop it now. Having a good time. Chunk found. Should stop after load data. Ooh, thank you. A little motivational bump for me. Is it 85? Thank you. Ooh. Yeah. What? But why does it crash? All of a sudden it crashes always here. I don't know why. Okay, let's try debugging again. Okay. Packet isn't found. It cleanups the stack. Rewinds and breaks. Huh. What is it that he doesn't like? Okay, let's lower the frequency. Oh, the debugger's still running. And try again with a lower frequency because I have no clue why it fails. Okay, let's drop the file. Something's off. Let me compare. CRC is okay. What are the changes? File system is new, okay. Okay, that's extra stuff. That's alright. RQs on sample. Okay, I can revert that. Oh wait, I can do this here. This was temporary anyways. Why does it crash? You know what? We might hit the limit of the stack. We are already... RAM is used. Okay, 10 kilobytes for stack. I don't think it might be the issue. 10 kilobytes. What if we change the buffer size to 40k and test again and see what happens? Upload test file. We should also add the IRQs when storing data. Encode packet, tget time, encode byte, and then enable. Disable RQ. This is might help. Okay, read. crashed. Let me try something else. Like old code again. Let's do that. Packet found. Chunk states. Okay. That worked. Okay, where did we get data and how? Render hex preview, interpret data, chunk data. Interpret file data. Okay. Huh? Does it return with any data? Wait, oh, it might be 0 if there is no file, but it wasn't 10 seconds, so let's do that. Shoop. Oh, the stop between the time between stop and rewind isn't long enough. That's why it's still playing. Okay, what is our value? 165. So 10. Oh, yes. Okay. Done. Payload. Command is. Wait, what? Okay. Oh, there is the stop. Need to do this. Is the interpret file data is wrong? It's written false, huh? Done as promise. Oh, it's async. Oh no. Oof. That's the issue. Yeah, we don't do this here. We just interpret it. Alright. Yeah, that needs to be payload. Okay. Ah, yeah. File size, chunk and everything. Okay. That part works, but why does not? So we have decode packets. Encode frequency, sample buffer size, decoded data size, timeout. Why doesn't this part work? Chunk data, okay. Let's exclude everything. It might be off. Decoded bytes. Chunk buffer. Timeout. Packet found. Let's assume chunk is always okay. Or let's assume loaded sync, then we have 0, 1 and 35. The data is correct. I have no clue why it wouldn't work. Okay. We did a workaround and see if we can manage to what is the data? That's the chunk data. Show me the data. No data. Why is there no data? Payload, okay. Okay. Let's try again. Ah, chunk states not initialized. Damn it. Oh. Hmm. Okay, that's one reason. Yeah, it wasn't never initialized. I left it there because if you rerun it, it should only write the chunks that the state is basically maintained through the whole procedure, how often ever I will repeat that. So now we should see the file load. This is commenting out chunks of code to see if we can make it run. Okay, so 35 bytes file name zeros bitluni was here, it works. Okay, that's correct. Now I want it to be working without this hack here. Let's see if that works. Timeout. A time outage. Huh? That's a riddle. The behavior is okay when I insert chunk okay here. Otherwise, it's completely strange. It has something to do with how the optimizer works. I might need to nest all those exceptions here. I have no clue why it would work. Okay, it skips everything here. Andrew, can you upload like a blink sketch and then test with the multimeter the voltage? I would I would try to blink it, like blink each individual number and then measure the voltage. What if something here like the CRC is broken? Let's remove that part. Yeah, if you have a scope, then it's easier. Then you can basically encode the number of the pin in like the 8 bits or whatever that you send, and cycle through all the pins. Then that would be like you can identify with one sketch every single pin. Did I connect already? No. Ah. Okay. CRC calculation. CRC calculation. It is. That's what's broken. What if chunk size is wrong here? Okay, chunk size can't be wrong. Yeah, I'm still live. This crashes. Okay, let's do it again. See, okay, int CRC offset equals header byte count plus chunk size. Then CRC. Oh, yeah. and that's the chunk buffer. Did I ever check the chunk size? Yeah. And we have FCRC. Okay. This is the best I can get here. Okay, let's try again. Nope. It's completely done. Shoot. I need to check what's going on here. This is the issue. So let's try debugging this. Let's hope for the best that we can CRC that. 65 and CRC offset is 63. What is it? It makes it crash. It just crashes here. Okay. How about we convert it like that? Maybe there's some sort of alignment issues or whatever. Otherwise, I'm really without a clue. Also, we could add stop here somewhere. Failed. Yeah. Let's run it normally. I'm on this bugs forever. Are you kidding me? This worked? Ah. Alignment issues. Something's strange. I have no clue, but this worked. Chunk okay. Alright, that's strange. How can you find errors like that? So bad. Alright, we can read that stuff. I also want to show chunk data. Chunk, okay, we don't need that. Okay, main. We need some display here. Pre-lock. Class preview ID chunks. Chunks. Then we do. Chunks. Chunks element. chunks, and then we will handle file now. Interpret file data, preview element, and that's chunks element. Okay. Now we can see the chunks. Bloop! Oh, didn't read. What? Why doesn't it read now? Okay, let me write again. Now it died again. Timeout. Huh? Ten seconds. Ah. Oh wait, it reads more than one chunks. Oh, I changed that part here. It tries to read more than one chunks. Number of chunks found at least one chunk. And found at least one chunk must be okay here. Ooh, it's strange behavior. Okay. Let's try again without that. Hmm. What's going on? I should, each state that works, I should just commit. But this is the only thing that I changed on about the code. Okay, that works again. Marathon stream, yes. Okay, it also chunk data is correct. Let's repeat that. Now it doesn't anymore. Now it didn't work. Okay. I have one thing that I can try. Let me lower the threshold value to 50. It seems a little bit random. Maybe we are at the limit of the threshold. No. It's not that. Now it's stopped completely. Oh. Where's this coming from? Huge fly thingy. I thought my window isn't. I have a screen here. Somehow entered. Okay. I really want this to work, but I can't force it. what is going on here. 4 bytes. It's also messed up. It's not the right sync. There seems to be some noise there. Sync bytes found. Oh, that's without the sync. It's completely crap. No, it's including the sync. Why does it load 4 bytes even though it's not the sync here? Continue, sync bytes found. All right. This is so weird. Everything about it is so weird right now. Yeah, I know. I need to go to bed and check again why I rested. Yeah. Store data. Oh yeah, that's also, we have stored it like that, not encoded. But it should read anyways. Cascade, check that. Remove the silence before. If I include the silence again, this won't work at all. Wondering what's with the tape. It seems. Maybe it's wear and tear. Nah. Zero. Let's store it then. Yeah, I always resolve my issues during the shower or when I do gardening or whatever. There it is. Try again. Here it is. This loads, but what the fuck is this? Again. Yet another error. Okay. Ah, nah. Doesn't like it. The rewinds, it doesn't do anything else. It's strange. Chunk states. Wait, we want a 0 here. Okay. Oh, wow. This is it. That was my mistake. Okay. The chunks. Let me fix that again. That's log state. Preview payloads. Merge. Payload. Merge. How do you merge? Concat. Join. Payload sub array 1 join separator. Okay, I think state of chunks. Why did I upload? That was only the JS code. Okay. flat. You know what? I will just shift it. Payload. Shift. And then join. Okay. Bloop. And there is the 1 for the single chunk. Should we store a bigger file and try reading more than 1 chunks? Okay. Now it should only quit of timeout or if we read the last chunk. So actually should finish right away. Stop. Okay. That worked. Ah! Such a stupid mistake. Oh no. Okay. Okay, drop file to tape. Let's try Pac-Man again. And let's see if we can read it and what chunks will be correct and which ones will fail. Quite some bytes. 1 minute or something. Ah. Okay, multi-chunk file, people. This will be the final test. Multi-chunk file. Let's reload. So we have a clean thing, and now let's read the file from tape. It will take a minute. We could actually update the states, but I'm not sure if we can send fast enough to UART the chunk states. Maybe. There's only so much silence in between the chunks. I think we added 100 microseconds. How big is the chunk? 512 bytes. But it's flexible, we can change it to like 16 bytes or something. Let's see what we get here. I'm really curious if it's able to... Oh! 17? Why is it 17? Okay, Pac-Man, it has a size. I have no clue where this is coming from. But the file looks alright. 288, 8288. No, it's 288 because of the file name and stuff. Pac-Man CRT. And we have the file size in front of it. But why is this 17? 17, 17, 17. What? But it was able to read the chunks. Okay, let me check again. Why is it 17? And why commas? Oh, it's probably just joining by default with a comma. Yeah, it's joining by default with a comma, so it received it received a 17 there. But why 17? Oh, it's the count of chunks. The index or something? Chunk count, yeah. That's so stupid. Copy paste. Chunk state it is. Chunk states and I. Alright, peeps. Last bug fixed. Now we will receive the chunk states. Not in real time, but we can read from file. Okay, now we will see the actual state of the chunks. Which one failed their CSC and which one did not. Here we go. There will be one last test, and that will be with a huge file. All correct! What? No way! It restored all the chunks correctly. Oh, nice. Okay. No need to redo it. I'm wondering about real-time updates, but I can't do this. This will be difficult from within there. Here we go. This all the states. Okay, big test. Big test. Let's do. Let's do Star Wars. Then. Okay, 16 kilobytes of Star Wars. 2-minute wait. I'm wondering if we could like send also not all chunk data, but like individual chunk states. That would be cool. So we can live update each chunk that was correctly read. I might do that. Marathon stream, 6 hours already, huh? I really need to get fondue for streams like that. Ship it, yeah. Might be good. Wondering if I can. Oh, it's done writing. Okay. 2 minutes read. People, 2 minutes read. Maybe if we like restart the chunks and resync, that really might help doing it right. All right. Screen is recording. Let's see if we get finally the Star Wars C64 cartridge loaded. Just curious about the state of the chunks, how many chunks are broken. I will implement a progress bar. Here we go. 3, 2, 1. Done. No, not yet. Still writing. All right. Oh no. Okay, didn't find the first one. Error, error, and error. Okay, not bad, people, not bad. The problem is that we didn't get the first chunk, which was important to get the file name and everything. But all right, I mean, it is what it is. Okay. Damn. Oh, I'm done for today, peeps. I see you next week. I need to finish the video until this weekend. If that works, I have no clue. You jinxed it. Nah, that's alright. That's what we expected. 3 chunks, it's not much. I mean, the first one, it's strange that we didn't get it loaded. Good night, Christian. Good night, Chris. Bye bye, everyone. Good night, Watermelon. Good night, Sonic.